Hello everyone, and welcome to your linear algebra review on the determinants of products. My name is Jason and I work for the ASU Tutoring Centers. Now in the previous video, we talked about how the determinant might change if you use elementary row operations on your matrix. In this one, we're going to look at further properties of determinants involving either scalar matrix multiplication or matrix multiplication. Okay? So let's just I'm just going to give you the direct properties. So the first property is that if you take the product of two square matrices, that's important, both A and B in this case are square. Okay, so to calculate the determinant of A times B, they don't necessarily have to be square, right? If A were, say, a 3 by 4 matrix and B were a 4 by 3, their product would be a 3 by 3. Which is a square matrix, and so this guy you'd be able to calculate the determinant of, okay? But in this formula I'm about to show you, it says the determinant of A times B is the determinant of A times the determinant of B. You can sort of split it. So if A and B weren't both square matrices at first, like in this case, then determinant of A doesn't make any sense, and determinant of B doesn't make any sense. You can only take the determinant of square matrices. So even if A times B is square, the matrix A and the matrix B themselves have to be square in order for this formula to work, or for this equation to work right here. Okay? An important thing to note. So if both A and B are square, then this formula 1 always holds. The other important one is the scalar multiple one, the determinant of alpha times A, where alpha is some scalar. So what does this do? Well, it's not quite as easy as just taking the alpha out front. It's not quite that easy. In fact, you have to take the alpha out front to the nth power, where n is the dimension of A. With fancy terminology, so n is just the number of rows or columns, right? A has to be a square matrix anyway, so the number of rows equals the number of columns. So n is just the number of rows or columns that matrix A has. Why do we have to do this? Well, when you multiply some scalar times a matrix, you multiply that scalar times every component, right? Right, whatever these components are. I didn't give them names. They're squares at the moment. You have to multiply that by every single component. Well, if I were to factor out one of the alphas from, say, the top row, I don't know the best way to write this, but if I were to factor out the alpha from the top row, oof. There's not really good notation for that, I've come to realize. But if I were to factor the alpha out from the top row, right, that's a row operation. That's a row operation of multiplying alpha into the first row. And I'm also doing the row operation of multiplying alpha into the second row. And I'm also doing the row operation of multiplying alpha into the third row. So I'm doing these 3 different row operations for each row of my matrix. And if we remember from the last video, how does multiplying a row by a scalar affect the determinant? Well, you multiply the determinant by that scalar. So multiplying a whole matrix by alpha means in reality, I'm multiplying n many rows by alpha. And so I have to factor alpha out of my determinant n times. That's why it's alpha to the nth power. Okay? That's the theory behind why this equation is what it is. So we now know the 2 rules that we're going to be applying here. So let's see them in action. If we look at question A, we're looking for the determinant of A times B. If we look at what A is a square matrix. If we look at B, B is also a square matrix. Therefore, we're allowed to apply this first rule that we talked about. So determinant of A times B is determinant of A times determinant of B. They told us what the determinants were. So this is -7 and this is 5. So the determinant of A times B is -35. Okay. Question B is going to be very similar. Determinant of B times A, oops, determinant of B times A. Well, same concept, right? Both B and A are square matrices, so I can split them up. Determinant of B is 5, determinant of A is -7, so this is also -35. It's also -35. Okay, so that's A and that's B. Let me erase to make some room. Perfect. There we go. So looking at part C, oops, I got my ordering wrong. That's all right. We did part A and part C. So now we're doing part B. That's all right. So determinant of alpha times B. What is the determinant of alpha times B? Well, according to rule number 2 down here, that would be alpha to the nth power, where n is the number of rows or columns my matrix has. Well, how many rows or columns does B have? It has 3. So if I were to factor the alpha out, I'm really factoring out an alpha cubed times the determinant of B. Which, what was alpha again? Alpha was -3. So I have -3 cubed times 5. Okay. Which, if you do the math real quick, that's -135. That is part B. And then my last one, part D. Well, so we have determinant of alpha times AB. So first, let's factor out the alpha, the scalar, right? So if we're factoring out the scalar, we need to know how many rows or columns we have in our matrix. Well, our matrix here is A times B. So matrix A is a 3 by 3, matrix B is a 3 by 3. So if we were to multiply them together, out would pop another 3 by 3. So if we were to factor this alpha out, we'd really have to factor out an alpha cubed times the determinant of AB. So this was applying our second rule here, but then we can now apply the first rule, right? Because we have the determinant of a product of matrices. So in that case, because A and B are both square, we can factor it out like determinant of A, determinant of B. Okay. So then plugging everything in, we have -3 cubed times determinant of A, which was -7, times 5, which, doing the math real quick, gives you a positive 945. There you go. Wonderful. So thank you for watching. As I mentioned at the beginning of the video, I work for the ASU Tutoring Centers. So if you have more information about the free tutoring services we offer at all 4 major ASU campuses and online, please check out tutoring.asu.edu. For more videos like this one that go over specific concepts from your course, or maybe you want to see what upcoming review sessions we have for your course, go ahead and check out that link down below. So thank you again for watching, and have a wonderful day.